Hi, on the screen I have the 2023 paper for the Singapore Cambridge GCE O-Level Mathematics Syllabus 4052. Today we'll be looking at paper 1 and we're going to do question number 3. Now this paper is for the revised mathematics syllabus, which is syllabus 4052, with 2023 being the first year of examinations. Now 3a seems simple enough. We have to simplify this expression to c cubed d squared bracket cube, and I'm going to use the distributive law for indices. I'm going to do 2 cube and c cube bracket it to a cube, and I'll do the same thing for d squared. 2 cubed gives me 8, c cubed gives me 9, and d squared whole thing cubed gives me d to the power 6. And this is 3a. Seems simple enough. And then we move on to part B, where we have an expression 16 multiplied by 5 to the power of 4 plus 9 multiplied by 25 squared, which can be simplified to 5 to the power of k. And I have to use the laws of indices to find the value of k. And candidates in this question are required to show they're working throughout. Now it seems a bit intimidating at first because there's 16 and there's 9, so we're going to have to deal with working with bases, and this is actually a pretty simple question that we can work our way around with. So I'm going to start by writing 16 multiplied by 5 to the power of 4, 9 multiplied by 25 squared, which gives me 5 to the power of k. Now, to start off, what I can do is that I can rewrite 16 as 2 to the power of 4 multiplied by 5 to the power of 4, and then 9 I can rewrite it as 3 squared multiplied by 25 squared, which is 5 to the power of k. And then I can use this law of indices. When we have the same power, we can just combine the bases together and the index will be outside. I'm going to use this idea on this one. 2 times 5 bracket 4, so 3 times 25 bracket squared gives me 5 to the power of k. And then I have 10 to the power of 4. 325 will be 75 squared, which is 5 to the power of k. Now initially when I did this paper in the actual examination setting, when I was in the exam hall, I did struggle with this question at first, to be honest. So throughout the course of this entire paper I might have no idea what I was doing at first, but eventually I figured it out. So I might get stuck along the way when I'm doing this question. I do see why this question may be seen as difficult for candidates who attempted this paper, because it seems to be a lot more trickier when we want to combine this side into a base of 5. Now I'm going to try to work my way around this one. Now you can definitely check with the calculator. 16 by 5 to the power of 4. That you can just cheat a little bit and see that when you type whatever's on the left side in the original equation, you get 15,625, which should be 5 to the power of 6. So 5 to the power of 6 is what we have to get ultimately. So it seems that this is not working at all. Okay, I'm gonna try to do this. I have 25. I can change that to 5 squared. And hey, would you look at that? On these two, I have a common factor of 5 to the power of 4. So what I can do is that I can factor out a 5 to the power of 4. In the bracket, I have 2 to the power of 4 plus 3 squared, which is 5 to the power of k. 5 to the power of 4, 2 to the power of 4 is 16, 3 squared gives me 9. 5 to the power of 4, this is 25. 5 to the power of k, 5 to the power of 4, 25 is 5 squared, 5 to the power of k. And now to use this law, I have the same base, different indices. I can add the power together while keeping the base the same. I'm going to use the same idea to do this. So I have 5 to the power of 6, which is equal to 5 to the power of k. And yeah, I'm getting really close to the answer. So eventually, equating the index, I get k equals to 6. Voila. And yeah, that is question number 3 of this year's maths paper for the Singapore Cambridge GCE O-level examinations.